Hello, ladies and gentlemen. Today we're going to learn about distance and how to find the length on a graph. You are going to need something to write with, a calculator, and that purple foldable I gave you in class. So when we talk about finding distance, we're going to be talking about finding the segment length. Okay, segments can be on a graph, and how are we going to find that length? So for example here, let's find the length of the segment between the point A, which is 4, 0, and the point B, which is 4, 5. So graphing that on my coordinate plane, A is at 4, 0. I'm going to make a point there. And B is at the point 4, 5 up here. So the segment then is the straight line between the two. Sorry, my line's not very straight. How would we go about finding the distance of this? Well, some of you might be thinking, well, that's easy. I just have to count the boxes between because this is a straight line. So 1, 2, 3, 4, 5. So the distance from these 2 points would be 5 units. So then I talk about, well, what happens if I find a length that's not on a straight line? So let's plot these 2 points. I'll plot these in blue. Okay, the segment between 1, 1, so 1, 1, and -2, 3. Okay, so now when I look at this segment, notice that this segment's not on a line. It doesn't go from the nice corner to corner of my coordinate plane box. So how do I go about finding something like this? Well, think back a little bit. Is there anything I can maybe construct to look at it a little differently? If I just draw in a triangle, or I use lengths that I know, because I can count these. So this side would be 2, and this side would be 3. So now I have 2 sides of a right triangle. How am I going to find the third part of that triangle? Think back to your 8th grade skills and what's going to help us solve this. Maybe an equation that looks something like x squared equals 2 squared plus 3 squared. Do you remember what that theorem is called? If you guessed Pythagorean theorem, you would be correct. So when we're talking about the Pythagorean theorem, what even is the Pythagorean theorem? Well, it's a squared plus b squared equals c squared. If you don't have this in your notes, you don't remember, make sure you write that down. We have to make a mental note that c is always my hypotenuse, or the segment, the side of the triangle, across from my 90 degrees. So let's talk about what it means to be a right triangle. Right triangle is 2 sides that form a right angle. So in the corner here, these 2 sides are going to form a right angle. The 2 sides that form the right angle are known as the legs of your right triangle. The side that's opposite of that right angle, so if we look here on our little diagram, side opposite of that right angle is called your hypotenuse. Now this is important because in your Pythagorean theorem, C always stands alone. You add the 2 legs together to equal your hypotenuse. So let's get a formal definition of the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs of that triangle. So looking at your picture here, this is saying that the hypotenuse, which is across from your 90 degrees here, which is C squared. Okay, I'm squaring the hypotenuse and I'm adding the squares of both my legs. And here my legs are a squared plus b squared. So if we look at that in words, we'll see that the hypotenuse squared, which is c, equals one leg squared plus the other leg squared. So let's see if we can try an example using the Pythagorean theorem. In this example, we're told to find the length of the missing side. Looking at our triangle that we're given, the missing side is c. Now, since c is across from my 90-degree angle, we know that that's the hypotenuse. Okay, so my Pythagorean theorem tells me a squared plus b squared equals c squared. C is always that hypotenuse. Okay, I'm going to make c just an x. So I don't know what the hypotenuse is, so I say x squared is equal to. Now I'm adding a and b, so we can say 5 is a We can say b is 12. It does not matter since you're adding them together. So then I get 5 squared plus 12 squared. Bring down the x squared because we still don't know what it is. 5 squared is 25. 12 squared is 144. Now I can add those two numbers together, so x squared equals 169. Now thinking back, how do I solve for x here? How do I get rid of that power of 2? If you remember correctly from Algebra 1, we have to take the square root of both sides to get rid of the x squared. So we're left with x on the left-hand side. Now anytime I take a square root, I always get plus or minus. We know what the square root of 169 is. You don't type this into your calculator, you should get back 13. Now thinking of that, I have positive 13 and I have a negative 13. Can I have negative 13? That's going to tell me that this distance right here is negative 13. Can we have the negative distance? Absolutely not. So my only answer here would be C is going to equal 13. So let's look at our first example, finding the distance of a segment. So here we have the point 1, 1 and negative 2, 3. We have the segment already drawn for us on our coordinate plane. How are we going to go about finding the distance? Well, similar to that very first example, we want to try and construct a triangle because then I can use the Pythagorean theorem. So I'm going to draw a straight line down from my point all the way over to my other point. So here I'm forming that triangle. Sorry about those extra lines. Okay, now these segments I just drew in green are easy to count the distance of because they're on the straight line. So here I have 2, and on the bottom I have 3. I still want to find this distance, this unknown here, this x there. And how do I find that? Well, we're going to use the Pythagorean theorem. X is across from my hypotenuse, so that's going to be my c. So x squared equals, take the two legs and square them and add them together. So we get x squared equals 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Again, to get rid of that power of 2, I take the square root of both sides. X equals, remember taking the square root, I get plus or minus the square root of 13. It's not a perfect square, so I leave it as the square root of 13. Or to better understand what that number is, I can type it into my calculator and get back a decimal. So this is going to be approximately 3.61 units. That's telling me that segment over here, this x value is 3.1 or 3.61, excuse me. Can it be negative 3.61? No, so it's only going to be the positive 3.61 because we can't have negative distance. In example number 2, we're trying to find the distance between the point 3, negative 2 and negative 1, 4. Now we don't have a graph for us, so I'm going to go ahead and create a graph and plot both of these points on my graph for me. So 3, negative 2, and negative 1, 4. So I plot those points on my graph, draw the segment to connect them. And again, since this isn't on a straight line, I can't just count the boxes between them. So I have to create the triangle myself. So I'm going to drop a straight line down from the point and then all the way over to my other point, creating that right angle here. Now this left leg, if I count, there's 1, 2, 3, 4, 5, 6 units. And the other one I have 1, 2, 3, 4 units. So now I know those two are 6 and 4. If I have to find this length, my orange length, it's across from my 90, so it's my hypotenuse. So again, I'm going to use the Pythagorean theorem. X squared equals 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16. Okay, 36 plus 16 equals 52. And again, to get rid of that x squared, I take the square root of both sides. So x equals plus or minus square root of 52. Again, can I have that negative distance? Nope, but if I want to understand what this length actually is, I can type the square root of 52 into my calculator, and what I get back should be 7.21 units. Remember, it's not the negative anymore because I can't have that negative distance. Let's try one more example here. Find the distance between the points -1, 4 and 5, 7. Again, since there's no graph given to me, I have to then create my own graph. So looking over here, I'm going to go -1, 4, make a point, 5 all the way up to 7, and make a point. Connect the 2 points with the line segment. Okay, since it's not a straight line, again, we have to construct that triangle. If I construct the triangle, I'm going to draw this one all the way over to where my other point is, and then bring that one straight down. So now here my triangle is kind of backwards, but it's still a right triangle. I still created that 90 degrees. So let's count up both sides. This side's going to be 3, and 1, 2, 3, 4, 5, 6, and my bottom one is going to be 6. I do not know my hypotenuse, so again, I have to figure that out using the Pythagorean theorem. X squared equals 6 squared plus 3 squared. 6 squared is 36. 3 squared is 9. 36 plus 9 is 45. Get rid of that power, I take the square root. X equals plus or minus square root of 45. Can I have the negative? Can I have a negative distance? Nope, so I'm only going to get one positive answer. And once I type square root of 45 into my calculator, you should get back 6.71 units. Now, as for most things in mathematics, we have this formula that we can use. Basically, this is exactly what we're doing, and we could use the Pythagorean theorem to derive this formula, but this is just another formula you might have to memorize. So if the Pythagorean theorem does not make sense to you, you can use this distance formula. So why don't we write it down just so we have it as a point of reference? But use this distance formula, x squared, so you take the 2 points, you take the first x, you subtract the second x, and you take your y's and you subtract those, and then what you get after subtracting the x's, you square, and what you get after subtracting the y's, you square, add them together, and then you should get the square root. How is this the same thing? If you would like to take some time in class, you and I can derive it together, but it's too long to have to do it on this slide. So then you have 3 more examples in your notes, and I'm going to have you try these examples on your own. So come to class tomorrow with these 3 examples done. I will check your notes for credit. And once again, I thank you for taking good notes. I will see you in class tomorrow.